Alright guys, this is the last graphing question. We're going to do it the same way as always. We're going to reduce first. To reduce this time, I'm going to factor, like always. So this is x factors to, x minus 1, x plus 2. By the way, when you see these questions like this, one thing I would check first is if the bottom is, if it happens to be a factor of the top. Because a lot of times, just the way that they write questions is they'll write it so that there will be some cancellation. Now, that's not guaranteed. It's not always the case, but that's one thing I would look for to see if maybe that is the case. And in this case, it is, right? Because x times x is x squared minus x plus 2x. That gives me the positive x in between. Negative 1 times 2 is negative 2, so it factors correctly. And since I have that, then I can actually cancel, right? I can cancel the x minus 1s, and so in the end, I just get this, x plus 2. So this original function, this rational function, is actually just x plus 2 in disguise, except with the caveat that x cannot be equal to 1, because then I'd be dividing by 1, right? That's the necessary restriction on the domain. Okay, so now we go to graph this thing. We need to know what the zeros are. But there's only one zero, which what's going to make this 0 is x equal to negative 2. So the 0 is negative 2. Now what about horizontal asymptotes? Well, horizontal asymptotes, nope, there are none. What about vertical asymptotes? Nope, there are none, because the final expression has nothing on the bottom, right? So what is the graph going to look like? It's just going to look like the graph of this final simplified function, x plus 2, but that's just a line. And it's a line more specifically that crosses through the y-axis at 2, right? That's the y-intercept. And it has a slope of 1. M is 1 over 1, so 1 up, 1 over. Just draw a dot like that. And then connect the dots. Okay, see if I can draw this line straight. Not so bad. Okay, so that's the graph right there. There's one thing I should watch out for though. It's when x is equal to 1, I have a restriction, right? So x cannot be equal to 1. So right where I'm at 1, actually, that point is not there. I just want to draw a circle to indicate that it's missing that 1 point. But otherwise, the graph looks just like y is equal to x plus 2, or f of x equals to x plus 2. Okay, that's it, guys. That's the last graph.